Good morning, class. Here's exam 4 review covering from chapter 5 to 6.1, 4.7 to 4.9, 5.1 to 5.5, 6.1. And here's the third part, which covers from 5.2 to 5.4. 5.2, the definite integral. 5.3, the fundamental theorem of calculus, short FTC. And 5.4, indefinite integrals and the net change theorem. That's what we are discussing today. The definite integral. Suppose a continuous function f is defined on the interval of a to b. It's a closed interval. The interval is divided into n subintervals, where delta x is b minus a over n. That's the width. X sub 0 is a, x sub 1 is a plus delta x sub 2 is a plus 2 delta x, and the last one, b, is a plus n delta x because we cut it into n subintervals. Then a Riemann sum is defined as follows. The integral of a to b f of x dx is equal to this Riemann sum. The limit of this summation of I going from 1 to n f of x of I delta x as n goes to infinity, they would be identical. That's the Riemann sum associated with that. F of x of 1 times delta x all the way to f of x of n times delta x, where delta x, as I mentioned, is b minus a over n, and if x sub I is a plus I delta x. In essence, this is the right endpoints, where x sub I is any point in between. But when we write it in this format, normally with that, we go with the right endpoints. Let y or equals f of x be a continuous and non-negative over the interval of a to b. Continuous, non-negative. A definite integral is the limit as n goes to infinity, equivalently delta x goes to 0. Whether we say n goes to infinity or delta x goes to 0, it means the same thing, of the Riemann sum of the areas of rectangles under the graph of y equals f of x over the interval of a to b. And so the area under the curve, if the function is continuous and non-negative, the area is the limit of this Riemann sum. That's a Riemann sum, and if it's continuous and non-negative, it represents the area under the curve. Let's look at every part here. This is an elongated S known as the integration symbol. Lower limit of integration A, upper limit of integration B, the integrand, and here's the variable of integration, also known as dummy variable. The reason is because the answer doesn't depend on the variable chosen. The dx simply indicates that the independent variable is x. This is a number, everybody. And this number represents the area under the curve if you're dealing with a non-negative or positive function. And it represents the difference of areas otherwise. If a portion is positive, a portion is negative, and so on. The integral of a to b f of x dx, the number, it doesn't depend on x. We could use any letter in place of x without changing the value of the integral. For example, if I use t here and I got to change this one to t, these two are identical. Its approximation is the Riemann sum, the summation of I from 1 to n of f of x of I delta x. The sum called as the Riemann sum, and it becomes precise if we take a limit and we let n go to infinity. All right, so the integral of f of x, the x from a to b, is the limit as n goes to infinity of this summation f of x of I delta x as I goes from 1 to n. So now here's the sum, the summation notation, the Riemann sum in the interval of 0 to pi. And we want to express that as a function of f of x dx from a to b. So the right side is given. We want to write the left side, if you will. And so the very first thing we notice we are going to compare this to what is given. So when we compare, the very first thing we notice, a is 0, b is 2 pi, delta x, b minus a over n, 2 pi minus 0 over n, or simply 2 pi over n. We are comparing first. Then we are evaluating delta x. So by comparing, we have a and b, and now we are evaluated delta x. Also, x sub I is a plus I delta x, 0 plus I times this one. Simply put, 2 pi I n. So a, which is 0, I times 2 pi over n, so 2 pi I over n. So what we are looking at, f of x sub I, so as you can see, by the way, 2 pi n, you see that? Delta x is the same as dx. Okay, delta x is the same as dx. So f of x sub I is sine of 2 pi I over n. And that shows that if instead of x sub I, we have f of x, it is sine x, and in the interval of 0 to 2 pi. And so this becomes the integral of f of x dx, sine x dx from a to b 0 to 2 pi. So the point is figuring out this function, you want to make sure it's sine x. It's not sine of something else. That's why we want to go through this process. It may be something else. Now, this is just expressing one format to another. Now, we want to evaluate this using the summation formulas. I want to tell you that evaluating this using the fundamental theorem of calculus, it is extremely simple. There's really not much to it. Okay, there's not much to it. This one, on the other hand, to calculate it, it's a little bit involved. Again, later on we learn this. We will look at that. But for now, we want to come up with the answer. It's important to remember this from algebra. Summation of 1 is n if I goes from 1 to n. Summation of c is n times c if I goes from 1 to n. Summation of I is n times n plus 1 over 2. Of course, I going from 1 to n. Summation of I squared is n times n plus 1 times 2 is 10 plus 1 over 6. As I goes from 1 to n. And I cubed gives us n squared times n plus 1 quantity squared over 4. We're going to use this in a moment, and I'll show you how to use that. So according to this, the function is 1 minus x squared, and it's going to go from a to b, meaning 0 to 2. According to this, f of x is 1 minus x squared, and a is 0, b is 2. So that's the first thing we need to notice. Now, x sub I is a plus I delta x. And delta x is b minus a over n. So delta x is b minus a over n, or 2 over n. A plus I delta x makes that 0 plus 2i over n. So let me quickly show you delta x b minus a over n, which means 2 minus 0 over n, or simply put, delta x is 2 over n. So that's the first thing, and then x sub I. All right. Now the next step is to develop this the limit as n goes to infinity of I from 1 to n, f of x sub I delta x. So we want to write f of x sub I times delta x. We already have delta x, which is 2 over n. F of x sub I, we came up with x sub I being 2i over n. So basically into this function goes 2i over n. So this is f of x. F of x sub I is 1 minus 2i over n quantity squared times delta x, which is 2 over n. So I want to make sure we understood this. 1 minus x squared, 1 minus x is replaced with x sub I. This is x sub I, everybody. And this is delta x. Again, we are using this formula, f of x sub I, delta x. And from here on, just about everything is algebraic. So let's do that. 1, I'm going to multiply by 2 over n, I get 2 over n. I'm going to multiply it by this one. This one, 2 squared is 4, so this is 4 I squared times 2 becomes 8i squared. So minus 8i squared, this is over n squared, and n becomes n cubed. In other words, distribute, I don't believe anybody has any problem with that. Now, since we are going to use those, we are going to make each and every one of them look like that by first and foremost making up 2 summations, the summation of this piece minus the summation of this piece. Summation of this piece, I can take the 2 over n out and I have a 1. Summation of this piece, I can get minus 8 over n cubed out, and summation of I squared. Notice, I'm going to leave 1 in here, and over here, I must leave I squared because I goes from 1 to n. I don't have to leave those inside. Now, I'm going to evaluate each piece. This one, I'm going to replace it with n. This one, summation of I squared. I'm going to replace it with n times n plus 1 times 2n plus 1 over 6. So pay attention to how we do that. I hope everybody's clear on that. Now, it is clear this is true. What happens up here? Now, remember, we are going to take a limit of that, okay? Therefore, I want to simplify this in the following manner. This is to the numerator. I hope you see n times 2n. If you just multiply the leading terms, this one times this one times this one times this one gives you 16n cubed. 16n cubed at top, and a lot more. My point being, you don't even have to evaluate everything. You'll see in a moment why. The bottom is 6n cubed. So this integral is equal to the limit of this as n goes to infinity. So this is 2 minus 16n cubed and a bunch of terms over 6n cubed, right? Again, is there anything else? Yes, but they are going down as far as the degree is concerned. And so you put it into the limit. This is 2, and I hope you realize because the degree is the same, if you recall, we've discussed that before. The answer is just the minus 16 over 6 over takes over. If you remember, when we take a limit of a rational expression, when the degree of the numerator and denominator are the same, leading coefficients will take over. So 2 minus 16 over 6 and that is minus 2/3. I'm going to assume everybody can see this as minus 8/3. 2 minus 8/3 is negative 2/3. Now, this could be done with FTC a lot faster, and we'll see it later. Use the signed area interpretation of the definite integral to compute this. Now, it is important to understand what function you're dealing with. The function is this, meaning y or f of x is x, and the interval is -1 to 2. That's the first thing as you read the question. Now, this y equals x is a line that goes through the origin. This is the line. F of x equals x, or y equals x. Or y equals x. We want to go from -1 to 2. So we want this area, and we want the difference of areas because this is above the x-axis. This portion is considered positive. This is below the x-axis, and it's considered negative. Therefore, we want to calculate the area. Each one is a triangular shape. We can use a geometry. A equals 1/2 base times the height. As you know, this one has coordinates 2 and 2. So this distance is 2. So is distance 2. So half of 2 times 2, that area is 2. This one has coordinates -1, -1, which makes this distance 1, this distance 1. So half of 1 times 1 is 1/2. And so the integral is the difference of the two, 2 minus 1/2, which gives us 3/2. Now, it's coming up. I want to quickly show you that it is possible to use the fundamental theorem of calculus coming up. The fundamental theorem of calculus says if you want to integrate f of x dx from a to b, the result in it is a number. Find any antiderivative and evaluate it at the endpoints. The difference is the answer. And in this case, you no longer need the constant. So just for the sake of argument, in order for you to see what I'm talking about, this one becomes half of x squared, and I won't have a constant, and I'm going to evaluate it from -1 to +2, which makes it 1/2. First, you're going to put the upper limit 2 squared, then you put the lower limit -1, and as you can see, this ends up being 3/2. So that's the same answer. So what is the difference? The difference is this goes faster, especially if you don't have a geometric shape, okay? Now, in this case, I want you to try this on your own. The integral of 6x dx from -4 to 1 is -45, and you want to graph and use signed areas. I'm giving you the question, I'm giving you the answer. You can try it at home to make sure you can handle it. Use geometry to evaluate the integral of 9 minus x squared, square root of 9 minus x squared dx from -3 to 3. So what we have, it's the function f of x or g of x or h of x or y equals square root of 9 minus x squared over the interval of -3 to 3. Okay. Now, what do we have here? This is what I want to show you. We have a circle. And how do we know that? If I square both sides, I get y squared equals 9 minus x squared. By moving things, I get this one. And I hope you remember, in the case of x squared plus y squared equals r squared, it's a circle centered at 0, 0 with the radius r, and this one is with the radius 3. Okay, so that's the equation of a circle centered at 0, 0. And this is the equation of a circle. Again, reminding you, x minus h quantity squared plus y minus k quantity squared equals r squared, which is centered at h, comma k. I hope everybody remembers that. So that's very straightforward, okay? And if this is the case, what is the difference between this and this? This is a complete circle. This is the semicircle. If you put this one is the top half, if you have a negative is the bottom half. If you solve for x is the right half or the left half. Again, just reminding you of what we have seen in algebra before. It's a semicircle. So what is the area of a circle? We know the area. We know the area. So the graph is a semicircle. And we know the area of a circle is pi r squared. So this one is half of that. So half of pi r, which is 3 squared. So 9 pi over 2. And you keep it as such because this is an exact answer, everybody. This is an exact answer and you want to keep it. So what happens is that if you have a geometric shape, it works. But what if it's not a geometric shape? Then you have to go with FTC, which is going to be discussed shortly. Properties of definite integrals. Let f and g be continuous functions over the interval of a to b, definite integral at a point. If we take the definite integral of a to a f of x dx, it's 0 because I hope you remember for a very simple reason. Delta x is b minus a over n. So a minus a over n. Delta x is 0, you don't have any area. Okay. So any given point doesn't cover any area and it becomes 0. Some difference rules, the integral of a to b f of x plus minus g of x, you can cut them into 2 pieces. So as an example here, this is f of x, this is g of x, and then you add the 2 pieces and it becomes the green piece. If you have the integral of f of x dx and you multiply it by c, it's a constant multiple. You can put this in or out. So whatever that area is, gets multiplied by that number. For example, if it's 2, is 2 times that. That's all. If f is larger than or equal to g from a to b, so it doesn't matter what happens afterwards. We are just interested in the given interval. Then this integral of f of x dx is larger than the integral of g of x dx as we go from a to b. So if f is larger, that means f is above the g function, and therefore it covers a larger area. Bounding max or mean. If m is less than or equal to f of x less than or equal to capital M in this interval, then if you integrate all 3 sides, this gives you the integral of f of x dx, and this one is m times b minus a. This one is capital M times b minus a, which means, very simply put, if the function has some minimum, this is the function. The minimum occurs here. If you draw a rectangle, this area is less than the area for the function. And if this is the maximum, you draw this rectangle as the largest area. That's the bounding rule. This is very important. We do this often, the splitting or additivity. If we integrate from a to c is the same as integrate from a to b and then b to c. Notice the initial here is a, the end point here is c. So no matter how many you have, the initial and the end, if they are the same, However many points in between will do the job. So A to B, B to C, you can say it's the same as A to C in one shot. If you're dealing with A to B, it's the same as minus integral of B to A f of x dx. This is the opposite rule. As I say, if it's just a constant, you multiply by B minus A, that is the same thing, M, because actually when you anti-differentiate this, becomes Cx, and you plug in B and A. And non-negativity, if f of x is non-negative, larger than or equal to 0 from A to B, then the integral is greater than or equal to 0. Otherwise, it's not. Otherwise, it's the difference of integral. So the integration may or may not be positive. Okay, it depends whether the function originally is positive or not. So with that being the case, we can try this. We know that f of x dx, the integral of f of x dx from 1 to 3 is given to be 6. From 3 to 7 is given to be 9. And the integral of 1 to 3 g of x dx is negative 4. So those are the given. So for part A, we want to find 3 times f of x dx. We want this integral. So simply put, I take the 3 out and I multiply this one by 3. So I take the 3 out, multiply this one by 3, and I get 18, and I'm done. Again, I'm going to cut them into pieces. Something involving f, something involving g, and I take the 2 out and I take the negative 4 out. So first I do this simple process. And then this one, we know is 6. I'm going to replace this with 6. And this one, I'm going to replace it with negative 4. So 2 times 6 minus 4 times minus 4. 2 times 6, 12, plus 16 is 28. The key is here. 1 to 7. Well, we know 1 to 3 is given, 3 to 7 is given. So we can say this. First of all, number 3 we can take out. Okay. Actually, it's just f of x, not 3. We don't have it. So it's f of x, the integral of f of x from 1 to 7. And from 1 to 3 plus 3 to 7. So this part, this one, plus this one. This one is 6, this one is 9, they add up to 50. Finally, we have, again, this is a typo class, we have it's a negative sign, minus f of x. Okay, minus f of x dx. Well, it's the same as this one, with the negative sign in front. So we put the negative out. So minus 6 is the answer. So very straightforward. I want to make sure that we understand what happened here. So this one is not there. This one is a negative sign. Okay, minus f of x. That's what we have. I want to make sure that we are clear. All right. FTC, the fundamental theorem of calculus. The FTC is appropriately named because it establishes a connection between the two branches of calculus, differential calculus and integral calculus, and reminding everyone that the area under the curve is approximated by this, and it's exactly equal to this limit. If you Don't have the limit as an approximation. So this is identical to this, where delta x is b minus a over n and x sub I is a plus I delta x. And remember, this is again the difference of areas if the function is not positive. So it gives the precise inverse relationship between the derivative and the integral d dx of the integral of a to x f of t dt equals f of x. Let me discuss this. If you take the antiderivative of this and evaluate it from a to x and then differentiate it, it gives you the same function, but you have to plug in this variable. You can use anything here except x, f of m dm. This becomes f of x because the top is, and the bottom is a number. What is a? A is any number, 5, 2, negative 10, who cares? Because ultimately the derivative of a number becomes 0. So the FTC has two parts. Both of them are really the same thing. So if g of x is defined as the integral of a to x f of t dt, okay, then g prime equals f of x. In other words, the integral of a to b f of x dx, and this one, the integral of f of x dx from a to b is capital F of b minus f of a, where capital F prime equals f. This is important to understand. The integral of a to b f of x dx, this is a number. This is a definite integral, and it's a number. Capital F of b minus capital F of a, which means find any antiderivative, the difference, the answer. On the other hand, if you want to differentiate this, please understand what you're doing. You are differentiating this expression. That's the meaning of d dx, and you get f of x. Now, this is the same as this expression. I think it's easier perhaps to understand this. It's the same thing. Let's look at this concept first. Very simple. We are dealing with definite integral, which means the result must be a number. So when you are evaluating the integral of x to the power of 7 dx from 0 to 1, first, the antiderivative of x to the power of 7 is 1 over 8 x to the power of 8. I don't need a constant, because even if I put a constant, it goes away. I'll show you in a moment. You plug in number 1, this becomes 1. You plug in 0, becomes 0. So 1 minus 0 is 1 times 1 over 8. This is how you evaluate it. Okay. First, you plug in upper limit minus second the lower limit. So if I put, and it's easier to keep the 1 over 8 outside. If I put here 1 to the power of 8 is 1, 0 to the power of 8 0, and the answer is 1 over 8. Now, here's the tip I want you to pay attention to. Even if we use another antiderivative, capital F of x plus c. In other words, if I said over here 1 over 8 x to the power of 8 plus c, even if I put a constant, not a good idea. In the evaluation theorem, the result will be the same, because we get, now we're going to plug in b. This is upper limit b. This is lower limit a. So capital F of b plus c. So we're going to put minus capital F of a plus c. These two cancel each other. That's why in the case of an indefinite integral, we don't need to put a constant. Now, I hope you realize x to the power of minus 1 is the same as 1 over x. Therefore, the answer is, let me just write that. Please recognize this is 1 over x. The answer is a natural log, and we put it in an absolute value. Now, if you don't put it in an absolute value, it makes no difference, because both the lower limit and upper limits are positive. So first you plug in 2, you get ln 2, minus you plug in the lower limit, ln 1. As you know, ln 1 is 0, so the answer is ln 2, which is a precise answer. Now, I want you to compare this to this question. Again, it's the same, so it's just different limits, so let's write it. But this time, we have to keep the absolute value because the limits are negative. And remember, The domain of an absolute value of ln x is 0 to infinity. 0 is not included. So ln of the top, -1, minus ln of the bottom, -2, in an absolute value. So what happens, this is ln of the 1, this is ln of the 2, and ln 1 is 0, therefore minus ln 2 is the final answer. All right, 0 to pi, the integral of sine x dx. As you know, the derivative of sine is cosine, but the integral of sine is minus cosine, and I'm not going to put a constant because it's a definite integral, so minus cosine evaluated from 0 to pi. So I keep the negative out and I plug in pi, cosine pi minus cosine 0. Now, as you know, cosine pi is -1 minus cosine 0 is +1. So this is -2. Negative outside makes it +2, and we are done. The integral of 1 plus cosine t dt from 0 to pi over 2. Pay attention to the fact this is t, therefore 1 doesn't become x, it's t plus the derivative of cosine is negative sine, but the integral is positive sine, and we don't need the constant because we are evaluating. Okay, so we are here. We plug in pi over 2 and we plug in 0. So pi over 2 plus sine pi over 2 minus 0 plus sine 0. As you know, sine is 0. Sine of 0 is 0. So everything here is 0. Everything here is 0. So that goes to 0. Pi over 2, we're going to keep it. And sine of pi over 2 is 1. And that's the precise answer, everybody. That's the precise answer. You don't have to change it. We want to integrate 5x squared of x plus 3 squared of x dx from 1 to 4. So the very first thing is to change this to x to the power of 1/2. And this is the power of 1. So we have 5 x to the power of 3/2 plus 3 x to the power of 1/2. Why are we doing that? So we can use the power rule. So we are going to divide by 3/2 plus 1. So 5 divided by 3/2 plus 1, x to the power of 3/2 plus 1. We're going to divide by 1/2 plus 1, 3 over 1/2 plus 1, x to the power of 1/2 plus 1. And we don't need the constant because we are evaluating from 1 to 4. This is 5/2. This is 2. 3/2. This is also 2. So we plug in 4, and then minus, we plug in 1. Let's see what happens. First and foremost, 1 to the power of 5/2 or 3/2 is 1. So this is 1, this is 1. So 2 and 2, this whole thing is 2 plus 2, 4. So that I want to get it out of the way. It's very fast. Again, this is our elementary algebra. I want to deal with 4 to the power of 5/2, which is square root of 4 to the power of 5. And that is square root of 4 is 2. 2 to the power of 5 is 32. Square root of 4 is 2. 2 cubed is 8. So we have 2 times 32 plus 2 times 8 equals 16 minus 4, and as you can see, adds up to 76. Again, I hope you realize, let me just do this for you. This is the only calculus step here. This is the only calculus step here. So over here, not calculus, not calculus. A lot of algebraic steps or even trigonometric steps, but not a lot of calculus steps. All right, when we evaluate this integral, first and foremost, we are dealing with what is called a piecewise defined function. F of x is 2 when x is between -2 and 0. It's 4 minus x squared when x is between 0 and 2. And just for the sake of argument, it may be defined, instead of -2 to 0, it may be defined from -infinity to 0. And over here, it may be defined from 0 to infinity. Conceptually, of course, that stops here and that stops here. This doesn't, it goes to -infinity and infinity. But I just wanted to show you it could be that it's in this format. And so, how do we evaluate this when it's a piecewise defined function and we want to go from -2 to 2? From -2 to 0, we have to use this function. From 0 to 2, we have to use this function. That is really the key. That's all that matters here. Everything else is elementary like before. But I just wanted to show you when you have a piecewise defined function, you have to pay attention to the given interval. So this is only good from -2 to 0. That's why we put 2 times dx. This one, 4 minus x squared, is good from 0 to 2, 4 minus x squared. And don't forget you need to put dx. Now, the anti-differentiation is very simple. 2 gives us 2x from -2 to 0. 4 gives us 4x minus 1/3 x cubed plus from 0 to 2. So this, everybody, and understanding this, those are the only calculus steps. Now we just plug in, okay? So what happens when we plug in? We plug in 0 here, so 2 times 0 minus, we plug in -2 minus 2 times -2. Then we plug in 2 here, 4 times 2 minus 1/3 times 2 cubed, minus, then we plug in 0. 4 times 0 minus 1/3 times 0, you may recognize it's 0, you don't have to put it. So it becomes like that. So this one is this, and this one is this. And what I'm going to do quickly, I'm going to get rid of this because it's 0, and I don't have to worry about this because it's also 0. So it makes a perfect sense. So what do we have here? Let me use a different color here. So I have +4 here. I have +8 here and minus 8/3, which means 12 minus 8/3. And we should know 12 times 3/36 minus 8 is 28. So 28/3. So a lot of elementary algebra, not a big deal. Find the derivative of the function, and I'm going to remind you of FTC. We've been looking at this one so far, but now we're going to look at this one. And what it says here, this is your function f of t. Because this is a is a number. It doesn't have to be 0. You can have 10, 17. In fact, even -5 works. And then you just plug into this. So your answer for the derivative, not the function, g of x is equal to the integral of this. What is the derivative of that? Is the square root of 1 plus x squared, of course, because f of t is a continuous function. The reason this function, we call it f of t, is continuous because you remember when you have a square root, when you have the index which is even, what's underneath must be positive. I hope you remember that. This must be positive, right? And 1 plus t squared is always larger than or equal to 1. It must be larger than or equal to 0, okay? But we already know it is. So, and what you did before you would figure out where this happens, this is always the case. In fact, because t squared is positive, this is larger than or equal to 1. So the domain is all real numbers. So it's a continuous function everywhere. Because of that, the answer is g prime of x, or d dx of g of x, is the square root of 1 plus t squared. Replace the t with whatever it is, x in this case. This is by FTC. This is by FTC here, everybody. What about this one? Now, what happens is, if you happen to have x, you just replace it, and you want to see d dx of this. But if it's a function of x, by the chain rule, it can be shown that the answer is plug in and then times the derivative of that. I'll show you that, and I'll show you, in fact, a different method, in a sense, the proof of that. So according to this formula, if you want the derivative of integral of a to g of x f of t dt, so to compare. And then this is any number. Now you are going to write f of g of x. This is your f of t. First, maybe I write this for everybody so you can see. This means f of t sine t. Replace the t with x squared, and then g prime of x, right, times the derivative of x squared, which is 2x. Okay, so sine of x squared, and then times 2x. We're going to put it in front. Okay, I'm going to put that in front. Let's do it differently. Let's say we are going to integrate this. As you know, the integral of sine is negative cosine. We're going to evaluate it from 1 to x. So never mind the d dx yet. We're going to integrate this and then differentiate that. So d dx of minus cosine t from 1 to x. So I'm interested in finishing this and then taking the derivative. So never mind the negative. I'm going to put the x squared in minus 1 in. So notice this negative sign, I'm going to keep it. Cosine of the top, x squared minus cosine of the bottom one. So I want to differentiate this. So I have minus, if I want to differentiate that, minus. The derivative of cosine is a negative sign. So minus negative sign x squared by the chain rule times 2x minus cosine 1 is a number. The derivative is 0. So the derivative of this is 0 because it's a number. It cosine 1 or 5 or whatever that might be, who cares? It's some number, the derivative is 0. Cosine x squared, the derivative is minus sine x squared times 2x. And then we have the negative, which is this one. So let me make sure everybody understand that this negative is this negative. So when you multiply, you get sine x squared times 2x. Sine x squared times 2x, and that's exactly what we have here. So if you go with this method also, you will end up with the same answer. So in case you ever forget this, just integrate this part and then differentiate, okay? All right, let's make it more interesting. And again, we are going to write this because we want to, cover this pretty fast. If you want the derivative, this is one of those fundamental terms of calculus. This is f of t equals tan t. So you're going to put this one in instead of t, and then times its derivative. The derivative of x squared plus x is 2x plus 1. So tan of x squared plus x times 2x plus 1, and we put the 2x plus 1 in front. In this case, f of t is t squared. I want to remind you of this. Can be easily proved. If the lower limit is also a function, so let's say the top is h of x, the bottom is g of x. First, you plug in h of x and then times h prime of x minus, then you plug in g of x, f of g of x times g prime of x. This is very straightforward. I hope everybody is fine with that. And you can easily look at the proof that I have in my notes. So plug in sine x, you get sine squared. So t squared, plug in sine x becomes sine squared times the derivative of sine, which is cosine x, minus plug in tan x minus tan squared x times the derivative of tan, which is secant squared. And you don't have to move anything, that's good enough. So the final answer is sine squared x cosine x minus tan squared x secant squared. If you want to put the cosine in front, you don't have to. And we are done. As far as this one is concerned, we don't know the answer unless this is at top, because that's what we've learned here. So we just switch those two. When we do that, it creates a negative sign. So look at the negative sign. Sign goes up, one goes down, and now we have a negative sign. Now, again, your f of t is this. F of t is 1 plus t squared, square root of 1 plus t squared. So if I replace the t with sine x, and don't forget then, so I have the negative sign, square root of 1 plus sine squared x, and then I need to multiply by the derivative of sine, which is cosine x. This is cosine x. And so this negative sign remains, and we are done. All right, it's pretty straightforward, everybody. Indefinite integrals and the net change theorem, basically we have infinitely many solutions. And the net change theorem, in essence, is one of those FTCs. The integral of a rate of change in the net change, the integral of a to b f of x dx, is the integral of a to b capital F prime of x dx, or f of b minus f of a. This principle can be applied to all of the rates of change in the natural and social sciences. In essence, the net change theorem refers to using FTC. All right, so we want to do this, and the very first thing we do, we change this to x to the power 1/2. We make up two fractions, this one and this one. And this has, we've seen this before, this has exponent 1 minus 1/2 gives you x to the power 1/2, and the other one is to the power of minus 1/2. I want to make sure that everybody knows that, so I'm going to remind everybody I'm using a to the power of m over a to the power of n is a to the power of m minus n in these cases, okay? So everything we've done so far is algebra. We are going to use the power rule, so we're going to add 1 here and divide by it. So 1 over 1/2 plus 1 to the power of 1/2 plus 1. We're going to do the same thing here. We're going to add 1 here and divide by it. So 1 over negative 1/2 plus 1 to the power of negative 1/2 plus 1 and a constant. So this is 1, this is another 1. 1/2 and 1, that's 3/2. And when we divide by it, okay, so that's 3/2. So let's write 3/2. The other one is 1/2. When we divide by it, the reciprocal of this becomes 2/3. The reciprocal of this becomes 2, and we are done. So indefinite integral creates a constant, everybody. All right. How do we do this? We are going to use our trigonometric function and knowledge of trigonometry, where sine 2 alpha is 2 sine alpha cosine alpha. So sine 2x is 2 sine x cosine x. And now this sine x cancels out this sine x. The derivative of cosine is negative sine, but the integral is positive sine, so the answer is 2 sine x plus a constant. I hope you see this is the same as 1 over x dx. Okay, so it's a natural log, and we don't need a constant. We're going to evaluate it from 3 to 6. The reason I'm not using the absolute value because the limits are both positive, otherwise I must. So let me clean this up so you can see, in other words, let's say this one. So ln of the top minus ln of the bottom, and it's ln of 6/3 or ln 2. That may be easier to use, okay? A particle moves along a line so that its velocity at time t is given as v of t is t squared minus t minus 6. And it's measured in meters per second. We want to find the displacement of the particle during the time period of 1 to 4. Okay, so let's discuss a couple of things quickly. What do we mean by distance versus displacement? Displacement is the integral of v of t dt. And in this case, this is positive, this is positive, this is negative because it's below the x-axis, becomes a1 minus a2 plus a3. So these two add up, but this will be subtracted. However, the distance is the same thing, but we put the v of t in an absolute value. In essence, this one and this one gets added to the a sub 2. So the displacement is the integral of v of t dt from a to b, but the distance is the integral of absolute value of v of t dt from a to b. That's the difference, and I hope everybody's clear on that. Okay, so with that being the case, let's see what happens here. We want this. We plug in. This gives us 1/3 t cubed. This gives us minus 1/2 t squared. This gives us minus 60. I'm not going to put a constant. And I'm going to leave it for you to finish it. You have to plug in 4, it gives you some number. You have to plug in 1, it gives you some other number. Their difference, negative 9/2. So this is the displacement, which means the particle has moved this much, minus 9/2, which means minus 4.5. So we put positive 4.5 towards the left, assuming the right is positive. That's the concept. We want to find the distance during this time. The distance is the absolute value of v of t from a to b, or specifically 1 to 4. And you need to do the sine graph to figure this out. But I want to make sure we understand the difference by giving you this simple example. If I want to go from point A, let's say to point B, this is my displacement. However, maybe I didn't go straight. Maybe I went like this, then like this, like this, like this, like this, and then I ended up there, which means I covered this much plus this much all the way. So my distance is a lot more, again, assuming both of them are positive. I just went from point A to point B. Yeah, of course, in some cases, you can't go straight. So either I couldn't or I didn't want to, I covered this much. So what I've covered is the distance. But this is my displacement. That's why it's the absolute value. So conceptually, this is the case. So with that being the case, let me clean up. I need the room. So we are going to figure out where this function is positive, where it's negative by factoring it and using a sine graph. T squared minus t minus 6 is the product of t plus 2 and t minus 3. Now, although it goes from 1 to 4, and that's all we have to do, and we are discussing time, we don't have 0, but I want to show you how the sine graph works, regardless of what happens here in general. So t goes, and normally t can't go, okay? Again, I can't be negative, but I want to remind you of a sine graph. From negative to positive, at negative 2, v of t is 0. At positive 3 is also 0. So there are 3 sub-intervals. So you pick up what we call a test point. So TP short for test point. So to the left of negative 2, for example, you can pick negative 3. In between, you can pick 0. After that, you can pick a 4, 5. It's just checking. So what you do, it's easier if you plug in 0 here. I hope whether here or here, this maybe it's negative. And they're going to alternate because each one has degree odd. But if you plug in negative 3 here, it makes it easier to go here. It's negative and negative, the product is positive. If you plug in 4, becomes positive, positive, positive. So we have this. And what it means is this expression, v of t equals t squared minus t minus 6, is a positive from negative infinity to negative 2, union 3 to infinity, and it's negative between negative 2 and 3. Now, when I go back to the interval of 1 to 4, and I see that before 3 is negative, so from 1 to 3, I'm going to use the negative of this because this is the absolute value. From 3 to 4, because I'm just going from 1 to 4, I'm going to use the same function. So pay attention to this. To the left of 3, see, and why do we stop at 1? Because this stops at 1, okay? So to the left of 3 is negative, so 1 to 3. To the right of 3 is positive, 3 to y4 because it stops at 1. So I wanted to make sure this is understood. And now all you have to do, you negate this one. So you put minus t squared plus t plus 6 here. And you put the same thing here. This one gives you minus 1/3 t cubed. This gives you 1/2 t squared. This gives you 6t. And this one gives you the positive of that. From 1 to 3, 3 to 4. Now, this is a little bit tedious. You have to do the work. And I'm going to leave it for you to come up with the answer. It's really not too bad. I have a couple more questions. Let's quickly cover it. Many fish grow in a way that is described by the von Bertalanffy growth equation. For a fish that starts life with a length of 1 centimeter and has a maximum length of 30 centimeters, this equation predicts that the growth rate is 29 e to the power minus x centimeters per year, where x is the age of the fish. How long will it be after 4 years? Well, Since this is the rate, and pay attention to the fact that its rate is the derivative. So if L of x represents the length of the fish, this represents L prime or dl dx, and the initial value is 1. So by the net change theorem, by the net change theorem, the amount of increase is the integral of this function from 0 to 4 by the net change theorem. Remember, we're going to divide by -1, so we get minus 29 e to the power minus x from 0 to 4. We can keep the negative 29 out, e to the power of -4 minus e to the power of 0. This is 1. You put it into a calculator, you use a bunch of decimals, and because the initial value is 1, you're going to add 1. And then what happens is that they want 1 decimal. That's why 29.5. I'm going to quickly show you a second method, everybody, but we are using the net change theorem, okay, the net change theorem. So the second method is that, well, we found this. Let's find the general formula for L of x. So this was the amount of increase. So capital L of x is this integral, okay, this integral, which is minus 29 e to the power minus x plus a constant, and L of 0 is 1. So the same thing plus a constant, L of 0 is 1. So if I plug in 0, L of 0 becomes minus 20 e to the power minus 0 plus c equals 1. And this is e to the power of minus 0, or 0 is 1. So minus 29 plus c equals 1, and c becomes 30. And what do we want? The length at age 4, plug in 4. Now, what is the advantage of this? If the question was asked, how long will the fish be after 4 years, after 10 years, after 20 years? All you have to do into this formula, put 4, 10, 20, whatever the numbers they ask you. A bacterial colony increases at the rate of R of t, and pay attention, this is R of t, 2.2 e to the power 0.4 t bacteria per hour. If the initial population is 800, find the population after 12 hours. Again, this is using the accumulated change theorem. This is the derivative. So if capital R of t represents the population, and capital R prime or lowercase r of t represents the growth rate, the accumulated change, the increase in population over the course of 12 years, is the integral of that from 0 to 12. As you know, we're going to divide by 0.4. We're going to write the same thing. And this is the same as (22 divided by 4, or 5.5). We are going to plug in 12, come up with the answer, plug in 0, come up with the answer, and this is the answer with a whole number, because we are looking at the population, everybody. That's why we have a whole number, okay? Now, what was the initial population? 800. Let's add to it. That's the final answer. Quickly, a second method is to find the general function. If we go back to the function that we found here, we add a constant. So capital R of t is this plus a constant. And R of 0 is 800. So if you plug in, you get 5.5 plus some number is 800. That number becomes 794.5, or 800 minus 5.5. So this is your function, and you want it after 12 hours. You plug in 12, and you will get the same answer. Again, you can do it through different methods. Both are good. Here's the last one. We want to find the area between the x-axis and the curve y equals cosine x from 0 to 3 power 2. Remember, if we continue, becomes a complete cycle at 2 pi. That's the graph of cosine function. And so what do we have here? We want the area, and that's the key. The moment you hear area, you have to have an absolute value, because the integral of cosine x dx represents the difference of areas. So as you can see, this is above the x-axis, it's positive. So from 0 to pi over 2, we use cosine x. This is below and it's negative. And from pi over 2 to 3 pi over 2, we have to use minus cosine x. And that's really the key for this question. There's really not much there. So obviously, we know the derivative of cosine is negative sign, but the antiderivative or integral becomes a positive sign. So this is sine from 0 to pi over 2 minus sine from pi over 2 to 3 pi over 2. So everything else, this is the only calculus step, okay? Now we're going to plug in pi over 2 and 0 minus, we're going to plug in 3 pi over 2 and so on. Okay. So sine of pi over 2 minus sine of 0 minus sine of 3 pi over 2 minus sine of pi over 2. As you know, this is 1. As you know, this is 0. So 1 minus 0 minus sine of 3 pi over 2 is negative 1. So this is minus 1 minus this is positive 1. So please understand, this is 1, this is 0, this minus remains. This is negative 1, minus is this one, and this is 1. So what you're looking at here is 1 minus negative 2, which gives you 3. And by any chance you don't end up with a positive number, you've made a mistake, class. And for comparing and contrasting, what if we had this one without the absolute value? And I want you to pay attention to what happens here. This is absolute value. This doesn't have an absolute value. And I hope you can predict that this area is larger than this area. Therefore, this 2, because we're going to consider the sign now, the result must be negative. So cosine gives you sine, right? And now we're going to plug in 3 pi over 2 minus sine of 0. As you know, sine of 0 is 0. You don't have to worry about it. This is 3 pi. And the sine of 3 pi over 2, as you all know, is negative 1.